Greetings to all. Myself Ram Prasad, working as an assistant professor in the Department of Computer Science Engineering at Comrade College of Engineering and Technology. Today we are going to discuss the topic about forward chaining and backward chaining in artificial intelligence. And this is an outline for today's session. First, what is an introduction about the forward chaining and backward chaining, and next what is inference engine and examples for forward chaining and examples for backward chaining and the resolution and what are all the steps involved in the resolution. First, introduction. The reasoning, it's a major key components in an artificial intelligence that a system can allows logical inference and even solving a problems. And there are the two essential strategies in reasoning. First one is forward chaining, second one is backward chaining. These two approaches commonly used in artificial intelligence system to derive the conclusion or even to find a solution for the particular system using a set of facts or rules. Both these chaining plays a critical role in expert system, helping an AI to reach an logical outcomes in an effective manner. An inference engine, it's a core component of expert system and even it's a rule based AI model. It applies logical rules to the knowledge base to derive conclusion or to make any decisions. And even these strategies using a forward and backward chaining, from this searching technique it has some set of data or rules to provide a better answer, and it gives a better solution for that particular expert system. In forward chaining, the engine starts with a known fact and even applies all the rules to draw the conclusion, but in backward chaining it begins with the goal and work backward to check if all the possibilities and availabilities facts to support and to achieve that goals. And two clauses, first one is an horn clause and second one is definite clause, and even an horn clause a logical statement with the most positive literals. Let us consider an example. It has an if then else rules. If A or B, that implies to B, it means that if both A and B are true, then C must comes also a true condition. And in a definite class, it's a type of horn class that exactly one positive literals, that it's a rule based reasoning system to represents the knowledge. Let us consider an example. Rain implies to wet. This statement states that if it rains, then the ground will be wet. And first, forward chaining. Forward chaining is a data driven reasoning strategies in artificial intelligence. It starts with the known facts and applies rules to generate new facts or to reach the conclusions. The process continues till no new facts are interfered to achieve the goals. And this is an known facts, so n number of facts in a knowledge base. From this we can operate to the known facts. Even from that we can easily take a decision. The main strategies is what can happen next. That's the main questions asked in the forward chaining technique. Some examples of forward chaining. Let us consider a medical diagnosis system. The system starts with a known fact. For example, let us consider a fact 1. A patient have a fever. That's a fact 1. Second fact is the patient have a sore throat. The rule is if the patient have a fever and sore throat, they might have the flu. So the system applies the rules using these facts number 1 and 2, and the system concluded that the patient having a flu. So next, the conversion of these facts into first order logic, FOL. So forward chaining, facts are often represented in an first order logic and then applies these rules systematically. For example, the fact, if I consider an example, John has a fever and he has a sore throat. So the system identifies John as a subject and applies this rule to interfere that John might have a flu. The system concluded that the John has a flu. Second example, the fire alarm system. Let us consider a sensor detects a smoke or heat. That's a fact, and rules to trigger an alarm or an sprinklers. That's a conclusion. So the fact is smoke has detected. Second, the rule is if the smoke is detected, then we have to trigger the alarm. So the action is alarm can sound or even the sprinklers can on. Next example for the recommendation system, let us consider an example. The system like use an Netflix or Amazon, the user data have access and using these accounts, that's a fact, and they have to apply a rule and suggest some products or content, that's a conclusion. Let us consider a fact as an user watches an action movie, it's a fact. And rule is, if a user watches an action movie, recommended the similar genre in that application, even in Netflix or Amazon. So the action is suggest all the action packed films in that account, even on Netflix or Amazon. Next example is traffic light control. Let us consider the sensor monitoring vehicle flow as an facts, even the facts. It detects an high traffic detected on a road A. Next, the rule is, if the road A has an high traffic, extend the green light duration. So the action is green light on the road A stays longer, because that the fact is the road A has an high traffic. The rule is to extend the green light duration. So the action is the green light on the road A stays longer for few minutes. And even in smart home system, the sensor detects the environmental change, that's a fact, because let's consider a fact, if the room temperature exceeds more than 25 degrees Celsius, so the rule is, if the temperature is high, then you have to switch on the AC, that's a rule. So the action is AC will automatically activates. So the expert system conclude the action, the AC have to activate automatically. In backward chaining, it's a goal driven reasoning strategies, because it's used as a reverse engineering process. In backward chaining, the goal is main important. It starts with the goal or hypothesis and work backward to determine even it have an available facts to support that goals. The process continued recursively, breaking down the goal into a smaller subsets. Like in backward chaining also, it has an n number of facts in the knowledge base. From that operation on that fact, we have to take a decision making. But the main question is, why this happen? Why this happen in the backward chaining? Let us see some examples in backward chaining. First, let us consider same medical diagnostic system with the goal of determining the patient have an flu. First, the goal is, does the patient have the flu? We have to check, the expert system have to check it. The rule is, if the patient have a fever and sore throat, they might have a flu. So the goal is divided into sub goals. First one is to verify if the patient have a fever. Second one is verify if the patient have a sore throat. So the system works on background from the goal flu to check whether the patient symptoms, it have an fever or sore throat matches. If all the sub goals are verified, the system conclude that patient is likely have an flu. And even medical diagnosis, the doctor suspects a patient have an diabetics. So doctor suspects the patient have an diabetics, that's a goal, and seeks evidence to confirm it. So the goal is to confirm the diabetics. So step 1, it has to check if the blood sugar level exceeds the threshold value. Second step, if it's not, check the symptoms like frequent urinations or it's fatigue. Third step, to verify family history of the diabetics. So the conclusion, if all the supporting facts aligns, the diagnostic is confirmed. And next example is troubleshooting a car engine. A car won't start, that's a goal. So we have to identify what's the problem. So the goal is to identify the cause of the failure, why the car is not starting. So the step 1 is check if the battery is dead. So check if the functionals, like we have to test the fuel pumps of the car, and if the fuel pumps its work, it suspects the ignition system in the cars. So the root cause is, for example, faulty spark plug is identified, so the car is not working. And last one is a customer support chatbot. A user reports a payment failed method. Even we are using an online payment app, the customer has an goal to that's a payment is failed. To resolve this payment issues, step 1, ask if the card details are correct. Second step, if is, check the sufficient funds. Step 3, if the funds are adequate, verify the payment gateway connectivity. If all these details are wrong, then the conclusion pinpoint the issue. For example, I have mentioned the card is expired. So, in a forward chaining, it is a fact based, starts with an available facts and applies the rules to derive a new information by step process to forward the and give a conclusion. But in backward chaining, it is a goal focused and it's beginning with an hypothesis, and even it has to identify the set and rules to need to support the goals. And resolutions. Resolution is a theorem proven technique and it's solved by a mathematician John Allen Robinson in 1965. The resolution is used if there is an various statements are given and need to prove a conclusion for these statements. So, the resolution in a single inference rules can effectively operates on conjunctive normal form or normal clause. It's an CNF forms. So, the steps involved in a resolution is first converts all the known facts into FOL, that's an first order logic. Second step is convert these FOL statements into CNF, and third one is to negate the statement which needs to prove, that is a proof of contradiction technique. And last step is we have to draw the resolution graph, that is an unification. So, these are the steps involved in the resolution process. Thank you.